Hello everyone, welcome to Ramanujam School of Studies 0 to Infinity. This is Higher School Mathematics class 11th and in this series we are doing quadratic equation. This is lecture 5th and in this lecture we learn about the condition of roots. This lecture is delivered by Diwakar Bhagat. Before move further, we request all of you please watch the full content of this video to understand the concept well. Now, in previous class, we did the question based on sum and properties of roots of a quadratic equation, and we also form a quadratic equation if we have two roots, and we analyze the roots on the graph. In today's class, we will understand condition that quadratic equation may have a common root, that is, two quadratic equation have a common root. And second is condition that two quadratic equation may have two common roots, that is both roots are common. We also learn about the conjugate roots and we also learn about the irrational roots and its properties. So moving to our first slide, to find the condition that two quadratic equation may have a common root. So suppose we have two quadratic equation, namely quadratic equation 1, that is a x square plus bx plus c, this is equal to 0. Suppose this is first quadratic equation, and second quadratic equation is a1 x square, okay, plus b1 x plus c1, this is equal to 0. So this is second quadratic equation. Now suppose alpha is a root which is satisfied by both the quadratic equations. So alpha must be satisfied both quadratic equations. So we can write here a alpha square plus b alpha plus c, this is equal to 0. And we can write second quadratic equation as a1 alpha square plus b1 alpha plus c1, this is equal to 0. Suppose this is equation A and this is equation B. Now alpha is the common root, so this alpha must be lies on the graph of both quadratic equation, right? Now we have to solve these equation A and B in order to find the value of alpha. So by using cross multiplication, we can write here, see here, as the roots alpha also lies on second equation, so we can write here a1 alpha, right, a1 alpha square plus b1 alpha plus c1, this is equal to 0. So suppose equation, this equation is third and this equation is 4. Now we have to find the value of alpha by solving both the quadratic equation. Now here we use the ratio and proportion in solving the equation third and fourth, that is here we use the cross multiplication method. So we have the coefficient here, C, A, B, C and A1, B1, C1. Okay, so if we find the value of alpha square, so here we write alpha square divide by, if we have to find alpha square, then the this value, that is alpha square coefficient, this is cancelled out and we take the multiplication in the ratio bc1 minus b1c. So we can write here bc1 minus b1c. Similarly, this is equal to minus of alpha divide by, now in this case we have a, b, c, a1, b1, c1, so we cancel out the b containing row containing b and we have ac1, this is ac1 minus a1c. So we can write here ac1 minus a1c and this is equal to 1, since the coefficient of constant term is 1, so this is 1, and again we cancel out the column containing the c, so this is constant term, so this is cancelled and we have ab1, so we can write ab1 minus a1b, so ab1 minus b1c, okay, ab1 minus a1b, so this is a1b, okay, right. Now we have the ratio of alpha square, alpha and 1. So by using first two, we can write here, see here, alpha, this is equal to BC1 minus B1C divided by CA1 minus AC1. Okay, CA1 minus AC1. So this alpha is calculated from these two ratios. See here, alpha and alpha is cancelled out and minus sign multiply with B1C. So this is CB1. So we have here C1B minus B1C divided by CA1 minus A1C. This is derived from the first two, and if we look the second two ratio, so we from here we can write here alpha, this is equal to CA1 minus AC1 divided by AB1 minus A1B. So these are the relation between the coefficient in case of one common root. Now since both alpha is equal, so we can write here BC1 minus B1C divided by CA1 minus AC1. So this is equal to, we have CA1 minus AC1 divided by AB1 minus A1B. So on multiplication, cross multiplication, we can write here, this is equal to BC1, here we can write the condition BC1 minus B1C, right? BC1 minus B1C into AB1 minus A1B. So this is equal to, this is C1A, CA1 minus AC1, so CA1 minus AC1 to the power 2, because these are two factor, two multiplication. So this is the condition that two quadratic equation has a common root. So we enclose this in a bracket because it is very important formula. You must learn this formula. Now see here, if we have some parameter here, some corollary here, that if C1 is equal to C and this is equal to 0, if constant term is 0, then already we have x is equal to 0 in both terms. So C1 is equal to C is equal to 0 is this must not be equal to 0 simultaneously. If it is equal to 0, so this become a common root, that is x is equal to 0. And here we have a condition is that AB1 minus A1B, AB1 minus A1B, this does not equal to 0. Why? Because if we put AB1 minus A1B, so we have this denominator part, this denominator part is 0, which is division by 0 is not defined. So this is two condition. Okay, so this is the condition that two quadratic equation have a common root. Moving to the next one, to find the condition that two quadratic equation may both root common. Now here we have to see a condition that both roots are common. So if we have a quadratic equation A x square plus bx plus c, this is equal to 0. Suppose this is equation 1, and second quadratic equation is a1 x square plus b1x plus c, this is equal to 0. This is second quadratic equation. Now alpha and beta are the roots, okay, which is satisfied by both the quadratic equation. In this case, alpha and beta lies on the same equation that is 1, and as well as equation 2. So both roots, both equation have some proportion, that is the coefficient of a over a1, this is equal to b over b1, and this is equal to c over this is c1. So this is the condition that two quadratic equation may have both roots common. In this case, both equation represent the same curve multiplying by some constant number. Now if this can be also see that since alpha and beta, second method here is alpha and beta is the roots of equation first, so we can write here alpha plus beta, so this is minus b over a, and alpha into beta, this is equal to c over a. Okay, again alpha and beta is the roots of second equation, so we have alpha plus beta, so this is equal to minus b1 over a1, and alpha into beta is equal to c1 over a1. Now from sum of roots of 2 we have minus b over a, this is equal to minus b1 over a1, and from product of both roots we have c over a1, so this is equal to c, this is c over a, this is equal to c1 over a1, right? So from here we can interpret that a over a1, so this is equal to b over b1, and from here a over a1 is equal to c over c1, so we can write here c over c1. So these are the condition that both roots, both equation have a common root, that is alpha and beta. So this is very important, and again we boxed this formula in a box. Okay, and next slide here is we have to find the condition that two quadratic equation may have both roots common. So already we discussed this one. Now conjugate root. What do you mean by conjugate root? So imaginary roots of a quadratic equation with real coefficient always occur in conjugate pair. Means if roots are imaginary, suppose alpha plus I beta is one of the roots, so the second roots automatically alpha minus I beta, that is in conjugate pair. How we can see it as, since alpha and beta is a root of x square plus, suppose this is ax square plus bx plus c is equal to 0, since this is our imaginary root, so this alpha plus I beta must satisfy the quadratic equation. So we put the value of x, alpha plus I beta, so we can write a into alpha plus I beta to the power 2 plus b into alpha plus I into beta plus c. Here I is the iota, that is unitary complex number, so we can further calculate it, alpha square plus I square beta square. See here, I square beta square, okay, plus 2 alpha beta into I plus alpha b into alpha plus b into beta into I plus c. This is equal to, and here this is the bracket, this is equal to 0. Now as I square is equal to, we know that from the complex number I square is equal to minus 1, so we can write here a alpha square, okay, minus a beta square, okay, and the real part is plus b alpha, and the real part is c here, this is, and we can write here plus imaginary part as I into 2 alpha beta plus b beta, so this is equal to 0. So here complex number can be written as 0 plus I into 0, so imaginary part may be 0 and real part may be 0, so we can write here we have a alpha square minus a beta square plus b alpha plus c, this is equal to 0, and we have 2 alpha beta plus b beta, this is equal to 0. So this is the equation, which is, this is the condition that alpha plus I beta is a root of the given quadratic equation. Now suppose alpha minus I beta is the other root, suppose, so alpha plus I beta always also satisfy the quadratic equation, so we can write here a into alpha minus I beta square plus b into alpha minus I beta plus c, this is equal to 0, as here we assume that alpha minus I beta is a root of the quadratic equation. Now after solving we can write here, see here, a into alpha square minus, this is plus I square, that is minus 1 into beta square minus 2 alpha beta into I plus b alpha minus I into b beta plus c, this is equal to 0. So we can write all here, this is a alpha square plus this is a alpha square and minus a beta square, okay, and minus 2 alpha beta I plus b alpha minus I b beta plus c, this is equal to 0. So we arrange this in real part and imaginary part, and we can write here a alpha square minus a beta square plus b alpha plus c, okay. So this is real part plus imaginary part, we can write here 2a, okay, alpha into beta. So this is 2 alpha beta into I. So this is 2 a alpha beta I. If we multiply this with a, so here we can write here a plus we have beta beta b beta I. So this is equal to 0. Now in previous slide we see that a alpha square minus a alpha beta, a beta square plus b alpha plus c is equal to 0. So we can write here this is equal to 0 plus 2a alpha beta plus b beta also is equal to 0. See here, this one, this is also is equal to 0. So this is 0 plus 0 I. Hence we can say that if alpha plus I beta is one of the imaginary root of a complex number, then the second root will be always alpha minus I beta. So second root will be always in conjugate pair. So this is very important. So if we have a imaginary root and we know that this is 2 plus 3i, so automatically we have the other root that 2 minus 3i. So this is important, you have to learn this. Now moving to the next slide. Next slide is for the irrational root, and in this case irrational root of a quadratic equation with real coefficient always occur in conjugate pair. So if roots are in the form of alpha plus root beta, so other roots must be in the form of alpha minus root beta, that is in conjugate pair. How? So we can write here ax square plus bx plus c, this is equal to 0, and one of the roots of this quadratic equation is alpha plus root beta. So we put the value of x, alpha plus root beta, in place of x. So we can write here a into alpha plus root beta square plus b into alpha plus root beta plus c, this is equal to 0. On simplification we can write it as, see here, a into, this is alpha square, so this is root beta square is beta and this is plus 2 alpha root beta, okay, plus beta alpha plus b root beta plus c, this is equal to 0. So we can write here a alpha square plus a beta plus 2a alpha root beta plus b alpha plus, this is plus, we can write here c plus b root beta, this is equal to 0. So we have here a alpha square plus a beta plus b alpha plus c, this is rational part, and we have irrational part is 2a alpha in plus beta b into root beta. So this is our irrational part, okay. Now what we have here, we have to do, we can assume that alpha minus root beta is also the root of the given quadratic equation. So alpha minus root beta also satisfy the given quadratic equation. So we can write here a into, see here, a into alpha minus root beta square plus b into alpha minus root beta plus c, this is equal to 0. So we have in the previous section this is equal to 0. So we have here, this is the rational part must be equal to 0 and irrational part must be 0. So we put this value in this slide. So a into alpha square plus beta minus 2 alpha root beta okay, plus b alpha minus b root beta plus c, this is equal to 0. So this is a alpha square plus a beta minus 2a alpha root beta plus beta alpha minus b root beta plus c, this is equal to 0. So we can write here a alpha square plus a beta plus b alpha plus c, okay, minus root beta into we have 2a alpha plus b. So in the previous, here we see that the rational part, this is equal to 0 and this irrational part is also equal to 0. So we can put the value, this is equal to 0. So 0 minus beta into 0, so 0. So this is equal to 0. Hence we say that alpha minus root beta is also the root of the given quadratic equation. So in conclusion, if alpha plus root beta is one of the irrational root, then the other roots of the quadratic equation occurs in conjugate, and this root is alpha minus root beta. So this is very important. So you must learn this one. Now next, symmetric function of root. What do you mean by symmetric function of root? Symmetric function of root means if we have two roots, alpha and beta, okay, and if we interchange the position of alpha and beta and there is no change in the equation, so such pair is called symmetric root of function of root. As for example, suppose ax square plus bx plus c, this is equal to 0, okay. Now this is equal to 0, and suppose alpha and beta are the roots of equation. So alpha square plus beta square plus alpha beta, okay, is a symmetric function of alpha and beta. This is the symmetric function of alpha and beta. Why? This is because if you put the value of alpha in place of beta and the value of beta in place of alpha, there is beta square plus alpha square plus beta alpha. There is no change of this function. So this type of function is called symmetric function of root. This is important, and here we end our class. So in this class we learn about the here condition that a quadratic equation have one root, condition that quadratic equation have two roots. After that we saw here what you mean by conjugate root, and we prove here that the conjugate root occur in the pair. Same case happen in case of irrational root, and we also learn about the symmetric function of roots. So here we have completed our basic concept of quadratic equation. All the features, all the parameters, and all the higher school concept of quadratic equation has been discussed. In next class we started our question set 1. After that we also do a question set 2 and question set 3. After that we end the quadratic equation chapter. So if you think that this lecture is beneficial to you, then please subscribe this channel. Thanks for watching. Have a good day.